Alright, so I'm hoping this lesson is a review, but like I said, I'll always teach it from scratch so that I can have it my way. Pythagoras. It should be a review, but in case, what does Pythagoras' theorem tell you? In a right angled triangle only, the square of the hypotenuse, which is the longest side, is the sum of the squares of the other two sides. So the thing that would go in your cheat sheet is this. C, you can label it as the hypotenuse. Can you get that down, please? And I'll do a couple of examples with you. So you should have actually done that in year 8, year 9, and finally in year 10, but maybe rushed through it a bit in year 10. Can someone tell me what the opposite of squaring something is?
Square root.
Square root. So you'll see opposite of squared is square root, which you'll see is a little button like that. I think the Apple button like that has a little 2 on it. If there is no number on the root side, it's square root. So just a review of Pythagoras so that we can use Pythagoras in 3D. Here, you'll be able to know I'm not turning the boards around. This is it. I managed to swap out the Friday lunchtime yard duty so I can do the tutorials every day. I'm in full now. Alright, let's use Pythagoras to find example 1. Is x the hypotenuse in this situation?
Yeah.
Is it the long bit? So set it up like this. X is the one that I don't know. X squared is the hypotenuse, is equal to, it doesn't matter what order you do the A and the B in, so I'm just going to go left to right. 3 squared plus 4 squared. I haven't done anything with the, it's hard to do this angle. X squared is equal to 3 squared is 9 plus 16. X squared is equal to 25. Does anyone know off the top of their head what number do I times by itself to get 25? X is going to be 5. If you didn't know, you're not expected to know, use a calculator to find the square root of 25. So it's going to be 5 meters. Yes, question? The symbol for square root, you could have written it like this. You could have gone x is equal to sort of like a tick that extends over square root of 25, which x is equal to 5. You can write that. Okay. But because we're only general maths, you can always round to 2 decimal points. You don't need to keep it as a root like the methods kids would do. I'm sorry about the angle for you guys at the back, but you'll see why I did this. The angle just in a bit. You'll either laugh or you'll cringe or everything at the same time. What's this one? Example 2. Am I finding the hypotenuse again in example 2? Am I given the hypotenuse? Good. I don't want to give you a separate formula to find what A is. Put in what you know and then rearrange. Do I know what the hypotenuse is here? It's 20, and according to Pythagoras, 20 squared is equal to A. Let's say A was 18 squared plus the other one, which was x squared. I don't know what that is. I'm still not going to rearrange. I'm just going to work out what I can. What is 20 squared? It's 400. What is 18 squared? I don't know that off the top of my head. Just quickly. 18 squared, 324 plus x squared. Let's use our algebra skills. I want x by itself. I need to get rid of this, and I need to get rid of the squared. What kind of a 324 is that? A positive or a negative? Positive. So how would I get rid of positive 324? What's the opposite of adding 324 to something? Take. So if you took 324 from both sides, take 324. Is there going to be any numbers left on the right hand side? 324 take 324, what's left? Nothing. So the only thing left is going to be x squared equals 400 minus 324, 76. 76 is not a square number. It's going to be a bit nasty. So we use the symbol like we showed over there. X is going to be the square root of 76, which you can't work out by hand. Use the calculator, square root of 76.
Would we then round it to 9?
Round to 2 dp to be safe. Okay? Because that's a whole number. The answer, x, on my calculator it says 8.72 centimeters to 2 decimal points. But you're not technically wrong if you said 9, but then you'd be rounding to 0 decimal points. It's a bit too much. Round to 2 just to be safe, okay? So in year 10, I'm pretty sure you would have just done Pythagoras 2D, flat. The only addition in year 11, general maths, is that you're going to deal with it in 3D. Okay? There's no added formula for that. You just need to be able to visualize a bit. So who does art here? That can be helpful because you'd be better at drawing diagrams, but what I'm going to try to do is like help you imagine it because I built that whole box over there. Applying Pythagoras at this level should be easy if it's only 2D, but you need to deal with 3D. If you apply Pythagoras in 3D, you need to visualize where the 2D triangle sits. This means you may need to do Pythagoras multiple times. So I've got a situation here, I have a cubic box. These sides are all 20 centimeters, so it's 20 by 20 by 20. If I wanted to fit like a stick or a rod in there, what's the longest possible rod you can fit in that box? Is anyone game? So this is that crappy part that I said you'll laugh or you'll cringe. I can't have you on the video, so I made this. So you're gonna, if anyone's game, could you illustrate for me where the longest rod would sit in the cube? Is anyone willing to try that? Yeah, and so come around here and make sure that nothing of yourself goes along this line. Okay? And draw where you think the longest rod would go.
I'll let you know.
Yes, that's the point.
Oh, God.
Yeah, good.
You can get.
Get a little closer to your hand. I'm trying to think. What?
You don't need to get a rod.
You can get a lot
You
closer.
can get a little closer.
Like the edge of the whiteboard.
No, and even if you did go, I'd put a giant black box and.
It's not a straight line.
Okay, so yeah, sit down. She got the right answer straight away. So what normally, if I wasn't doing this crappy thing, I would have been like, is this the longest rod you can put in?
No.
No. Would it be longer if I went diagonally but still on the side facing you? It would be longer, but that's not the longest. Because what did she do? She made it even more 3D. Because right now we were still on the same one side. What did she do? She went from the front corner to a rear corner. So it's even more diagonal. Okay? Let me illustrate that.
The line itself is just shoddy.
No, yeah, because you were using a bloody using a bloody plastic pool cue. So I made this. This is exactly 20 by 20. Okay. Most people are skeptical these days, so I like to. Most kids are skeptical these days, so I like to prove it. Yep, 20 by 20 by 20. What I've shown here is, can you see that? On the back, you've got a little triangle with a black line through it. That's sitting flat on one of the sides. You're not thinking 3D enough yet, because the longest would be this. That's significantly longer, isn't it? That's longer than, that is longer than any of the sides. Is it much longer than any of the sides? It's like, bro, how am I going to fit that into that box? There's no way. But no, if you look, hey, if you look here, I'm going to place this with the sort of the vertical side in the back corner, and that corner in the bottom corner, like she did. Does that fit in there?
Yep.
Let's work out how long that is. Okay? So, how would we do that? We're going to have to do Pythagoras twice, because this triangle that she drew, the straight side is one of these. The straight side is like here, right? But the bottom of it goes along the bottom of this cube. See how, if you can draw, it's a bit easier to visualize. That diagram is crazy right now, okay? But there's two triangles here. This, so let's call that triangle 1, and then triangle 2 is sort of angled. So let's work out triangle 1. Triangle 1, so let's call that x. X squared equals, how long is side A, how long is side B in triangle 1? They're both 20, so it's going to be 20 squared plus 20 squared. So that's going to be 400 plus 4, 800. What's the opposite of squaring something? Square root. So x is going to be the square root of 800, which is not going to actually be a nice number. Square root of 800. 28.28 to 2 decimal points. So what have we just worked out? We've worked out how long it is from the bottom there across to the bottom on that side. We'll work this out. Getting there. We worked out that black line. That's all we worked out. Why is that important? Because that's the bottom of this. Okay? So you're thinking in 2D and 3D at the same time. So now we know this, x is 28.28. Is at the bottom of that weird sort of angled triangle. Do we know how tall this is of the angled triangle? It's still 20. It's nice. So triangle 2. So now let's call this something else. Well, let's call that y. Y squared equals 20 squared plus 28.28 squared. Let's add those together. 28.28 squared plus 400 . It's 1. So that comes to 1199.76 to 2dp. What's the opposite of squaring something? Square root. So y is going to be the square root of 1199.76. That comes to, on my calculator, 34.64 centimeters rounded to 2 decimal points. Okay? That sounds kind of ridiculous. That sounds a lot longer than 20 centimeters, right? But you just told me that this fit. I showed you that this fit. Is this longer than, is that longer than 30? Is that longer than the ruler?
Yeah.
That little bit's 4.6, okay? So hopefully that showed the maths lines up with my crappy cube. Nothing lined up with this crappy pool thing, but I thought that was fun, okay? Any questions about that process? So the hard part will be, and I'm expecting you to ask me questions about help to find the triangle, but I trust your ability to do Pythagoras. I think you can do Pythagoras fine, but depending on whether you do tech studies or you do art, it might be hard to pick out where the triangles come from. But that's fine, that's why you'll practice. Okay? Get that down. I'll write up what exercises I'd like you to practice, and then I'll leave you alone.